Anybody have any questions for Simon?
Yeah.
Yeah, I've got one. I guess I'll just go ahead and ask it, and that is, what's your expectation with regard to um, the protocol? Do you think one protocol will fit all of the ICROA organizations, or are we looking at three different protocols for three different organizations?
I think we're looking at different protocols for different organizations. My understanding of the process is that once we get one over the line, the others will follow more easily than if they were the first. However, each will need to be modified according to the different parameters of the standards. Don't forget that the standards kind of compete with each other, and so they do need to differentiate themselves. For example, with the VCS, I imagine the focus will be on the fixed carbon content within biochar, whereas with the gold standard, I imagine it'll be that plus co-benefits that will require certification. Where we're going with it at the moment is perhaps, and this isn't decided now yet, rather, but it's just an idea, is to have a relatively generic certification process that allows you to calculate the fixed carbon content of the biochar in line with the IPC statistics, which have been recently published. And then following on from there, in other words, once it's left the factory or the production site, adopting perhaps a more modular approach, which will allow for accurate certification that accommodates all the various different usage or application techniques that are emerging. So soil application, putting it into asphalt, using it as a water filtration material, et cetera, et cetera. So that's the current thinking, but it's still work in progress.
Simon, there's a question from George Kim Chafee.
Oh.
Saying, why wouldn't it make sense for the US to adopt the EBC standards or a modified version rather than reinventing the wheel?
Sure. Why didn't it make sense with the US? Yes, absolutely. If you're referring to reinventing the wheel as the process that I'm proposing to go through, then that's the process itself, that the first stage of it is to review all of the methodologies that currently exist. Everything going back to Carbon Gold's methodology, which was developed back in 2009. The IBI took a version of that and tried to put it through the ACR. We have Carbon Future, which is the EBC certification, and we also have Puro as well. So that there'll be a consolidation of all of those methodologies, or a review, if you like, and then they'll use that as the foundation and then build from there. So the EBC certificate will certainly be utilized. In my view, it is probably the most robust and thorough out there at the moment. And also it carries out that crucial bit of, what do you do with the biochar after it's been produced? Because in theory, with the Puro mechanism, Puro certification at the moment, you could buy a ton of biochar, the producer would get their certificate, and then you could stick it on your barbecue. But so you do need to monitor that final last mile, so to speak.
Okay, thanks.
Looks like an open question.
That answers your question. Yeah.
Everybody, what characteristics are optimal for feedstock from an agricultural application? How to grate fine prunings and straw residue, rate as biochar qualities? Anybody have a good answer for that? We have been training.
I didn't hear the question.
It's in chat. Can you see the chat? It's the second one. We have been training a lot of vineyard managers over many years on the conservation burn technique, which produces char. It's not super high quality, but actually we've had some tested and it's not bad. And that's worked well. I don't know of any tests other than, I think, Hans-Peter Schmidt. I'm not sure whether or not he used grapevines for his study in Tuscany. Does anybody know that? Yeah, I'm afraid I don't have any particular expertise in that. I'm not sure if does anybody else?
I think you have a lot of different, depending on the feedstock, you have different qualities of biochars. So here in China, last year you had 500,000 tons of biochar produced from wheat straw and corn stover. And you've got biochars from corn stover being fed and being used successfully in agriculture and Africa, places like that. You've got pits, nuts, and shells. So I think the answer is that you can use a variety of feedstocks, but the applications may slightly differ, and the quality of the biochar certainly will differ.
Again, for those who came in later, please enter your question into the chat box and point it towards a certain speaker or just to everyone. If you have any questions.
Yeah, I would just add to what Tom was saying that, you know, the big issue seems to be in terms of biochar quality with respect to ag residues and the like is, you know, the ash content and how high is that? And that also depends on production methods. So both are relevant. And for most things like, I think, vineyards and straw, the lignin content might be a little higher for the vines than it would be for the straw, but compared to the lignin content of some other feedstocks, it's relatively low. Like walnut shells, for example, has very high lignin, which tends to give you a higher, a more recalcitrant char at least. So I don't know if there's a quick answer other than it depends. They're all good, and it just depends on how it's made and what the purpose you're planning to use it for. I don't know if that helps, Stefan.
Another point is that if you're making it from grapevines and then you're going to return it to the vineyard, you are kind of recycling the minerals at least that the grapes use. So that's an advantage. You don't have to pay for inputs twice there. And the other big difference is density differences in feedstocks. So, and then like Jim said, temperature makes a big difference in quality.
Well, there are a lot of vineyards that are now looking for a more sustainable way than burning their material to process it. So we're starting to get a lot of interest there. So I think we'll get more data on that as, you know, in the years to come.
And that's just building on the traditional techniques of field burning. You know, it's always done for sanitation and also nutrient cycling. So it's really something that agriculturalists have always done.
Mm-hmm. Well, and that's part of what I was, you know, sort of what I was trying to say at the end. There are many, you have to meet people where they are, and it would be fantastic. I mean, our dream is to have, you know, regional pyrolysis, you know, in every community. And, you know, it's kind of like the model of the Stockholm Biochar Project and what Brett is trying to do in Colorado is to use the material that you have, you know, where you are. And in some cases you do it in the field. In some cases you could do it in a carbonator, in some, you know, or in other cases you could do it and take it to a nearby processing facility where you can capture the heat and use the gases. You know, there's no one way to do it. And so, you know, ideally we wouldn't, you know, maybe do as much burning as we do, but that's going to be a long way off before we have, you know, efficient technologies that we can take around, you know, other than what Kelpie's doing and what other people are doing, which is definitely a step up from field burning. So there is another question there about biochar as a feed supplement. Anybody want to tackle that one?
I can make a mention to that. Kelpie, I think you've done a lot of work on this as well. In the US, no. In California, yes. So that's the summary. I think Tom Miles, you've been kind of working on this as well. So charcoal was on the accepted list with USDA until I believe 2010. So there, I think there could be some loopholes with activated carbon as far as USDA is concerned. But in California, biochar just straight on through. In fact, I just had my most recent client purchase biochar for use as animal feed in trials right now to see how that's working, and we were able to do that fully above the board, which was kind of fun. So I'll leave that to anyone else who wants to add more.
Oh, I
meat
got
to
a
the bone
question.
there.
The California Department of Food and Ag then supersedes whatever the federal restrictions might be?
It works. I didn't. I looked at it briefly. It was confirmed at a high level, so we did kind of get confirmation from the person of concern. I don't recall the details of that right now, but I know that those questions were asked and answered.
So a year ago, the California Department of Food and Agriculture said we are following the Food and Drug Administration ban on charcoal. And then just within the last year, CDFA has approved at least 2 products. And so they have to meet certain criteria. And the testing that's going on right now at the University of Nebraska has been following over, I think, a 4-year period so far, a very careful managed program, which has been approved at every step by the Food and Drug Administration. In other words, FDA came out and said, we want you to prove these 3 benefits. There had to be a non-toxicity, no dioxins, a demonstrated beneficial nutritional benefit, some other things. And so Andrea Watson, who's doing the studies, has been chipping away at those tasks. And the first stage was done in vitro, no animals. The next stage was done with 1 animal, and I think she's worked up to multiple animals now. That's kind of the process. And then I think it's probably going to take, from a national point of view, it's probably going to take the Cattlemen's Association and the animal nutritionists and that animal husbandry community to buy off on it. At least that's been my experience with food or feed additives in the past.
What about the guy in Canada who was doing that study? Do we know, has he published a paper on that?
That was published, and I think it was primarily a reduction of methane emissions. It wasn't necessarily on animal nutrition, and the Food and Drug Administration has leaned on on demonstrating nutritional benefits.
I see. Okay, good.
I have some anecdotal reports from the study in Canada at University of Lethbridge, because I had a nice long conversation with the feed blender who provided the blends with the biochar. And what he told me was that the reduction in mortalities was significant, and that just from and the weight gain as well. And just from that standpoint, he was starting to use it with his private clients as well. So, if you just base it on methane reduction, there are a lot of other benefits to animal feed that have to do with animal health and weight gain.
Can I point out something? I have experience of this in Europe. I was co-chair of working group 3 of the cost action. And my co-chair was Dr. Saren Sohi from the UK Biochar Center. So what we did from the beginning all the way through 2016, the EU pumped in 9.5 million euros to do studies on all sorts of uses of biochar. One of them was double-blind studies on animal feed. It is legal in Europe to provide a blended char, and it has to meet certain requirements in the EU. There's an EU directive and also EU regulatory regulations that do that. In the United States, and I've been in the business of bringing innovations to the marketplace. One of them is going through FDA approval. The FDA approval that we would seek in our business would be the kind that's in Europe, where it's sold through veterinarians, kind of like a drug, and prescribed. And that's what the EU has done. I think the FDA, and I've had some conversations with FDA people here that I've done business with in the past, and they told me that they would prefer ultimately to have it regulated through the FDA. And Kelpie's absolutely true. It's right on, spot on. The big benefit is the mortality rate reduction in the cost action double-blind studies. all types of livestock showed a 50% reduction in mortality rate at a minimum. And that included not just cattle, it also included sheep, fowl, like chickens and things like that. So there's a lot of opportunity, I think, in that marketplace.
Wasn't there also an increase in live weight?
Yes, there are other things, but I think the big thing to the livestockers, the big issue to them, at least in Europe, is the mortality rate reduction. The weight gain is important, obviously, but that in itself was not the big deal. There's a huge market around the world for replacement, like for instance, if we're going to talk about mortality rate in cows, especially cows that are going to slaughter, right, for food. So the reduction in that is really important because there's a huge market in replacement. Most of our data showed that most of the deaths that did occur in cattle was mostly with heifers and calves, not the older cows that were on their way to the slaughterhouse. But remember, also another important point about this is that, right now we're all experiencing COVID-19, right? That's a zoonotic disease. That means transmitted from one species to another. The last time there was a big problem with livestock was in the UK, Ireland, and northern France, in which they had to wipe out all the cattle, every one of them.
Mad cow disease.
They had mad cow disease, which translates into Jacob Creutzfeldt disease in humans, and it killed a bunch of humans. But they got it really quick, and they wiped out a whole industry. Billions and billions of euros got wiped out. But we believe, at least from our perspective, is that's a great opportunity, because if you formulate it correctly, you not only reduce the mortality rate, but you also, especially in cattle, because they have 4 stomachs, you have the ability to probably inoculate the cattle against transmission of viruses.
Great, thank you. Anybody want to tackle Hugh's question?
Well, don't everyone speak at once now.
I have a question.
I'm actually putting that to Simon more than preferably, in that I've kind of gone through this in detail, and I'm quite concerned that especially the fixed carbon test, when you do it according to the protocols, is really taking the material to such a high temperature, it's changing it entirely. It's making a different material, and it creates a lot more fixed carbon. It makes it look a lot better on carbon sequestration, but it's not true. I mean, for example, sugar is 25% fixed carbon according to that test. And sugar will be a tough one to get a carbon credit for.
Just reading your question, Hugh. I'm not a methodology developer, so I'm not going to be able to answer this question with any degree of, or not the degree of accuracy that I think you require. However, all I can say is that I'll ensure that the process is carried out in the most thorough way possible. And also part of that process is an external third-party review. So any feedback of this kind can be incorporated into the development process.
It might be worthwhile to perhaps if you could connect me into that group, and I'll provide the studies I've done, and they can at least take them under advisement.
With pleasure.
Thank you.
Great. Okay. How about Jeffrey's question about renewable feedstocks?
Simon, I think you're going to be hot here. I think that this kind of, I've got some thoughts, and I'd like to kind of answer a little bit to that, but basically just formulate more questions and pass them on to you, Simon. I think one of the critical pieces of information here is the words emissions reduction credit. So biochar is a carbon dioxide removal, but during the process of biochar production and application and the waste management aspect, we can also have emission reduction stacking on top of and into the whole equation. And so, it's a really interesting thing. Biochar as a carbon dioxide removal, I think, is really important, but then how do we account for the emissions reductions associated with that? And particularly with food waste and things that are of low carbon content, how do we make sure that that they're not dinged too heavily, such as currently in America, the association APCO, I forget what the acronym goes for, but basically anything below 60% carbon is not biochar. And so a lot of the biochar made from manures, which could be a great product and have a great greenhouse gas emission reduction profile, would not even be acceptable as biochar under current America practice. So two things in there, there's the manure, and then there's also emissions reduction. Simon, I think I'd be curious to hear what you got to say.
Sure. Are we looking at this, the question from you in relation to the IBI and EBC standards?
No, the Jeffrey Hallowell to everyone, renewable feedstocks such as food waste, digestate, human waste, and manures often have less than 50% carbon content.
Yeah.
But they can get a 50% greenhouse gas emission reduction credit and need to be diverted from landfills. Will the total carbon footprint be considered for future standards rather than just percent carbon? And I think when he's saying percent carbon, perhaps Jeffrey, you can fill in here, but I think percent carbon.
Okay. So let me just get this straight. So you're talking about the entire life cycle. In other words, harvesting the feedstock all the way through to production and use, where the carbon reductions take place as part of that entire life cycle, not or production cycle, not just the fixed carbon content of the actual material. Is that what you're asking about? To make sure that that's acknowledged? Yeah. So yeah,
yes,
for sure.
Because the greenhouse gas emission credits are actually higher than what the biochar is worth, and in some circles, like Josiah mentioned, because it's 50, it's usually around 50 or a little bit under 50 carbon content. It's not considered as biochar, but it looks like biochar. but I'm getting more money on carbon credits right now, and nothing really for the biochar. So that's kind of wrong. We could combine it together. It could add more value and create a new market or a bigger market.
Yeah, I mean, one of the methodology developers that I'm talking to at the moment, we're looking at sort of project cycles just as you've described. So if you were, for example, to take a pile of biomass residue on a almond shelling processing site, for example, that goes all the way through to being turned into biochar for fertilizer additives. This is just an example. Then there are carbon assets multiple carbon assets sit within that entire process over and above the fixed carbon content of the biochar that's produced by the pyrolysis machine. So even to the point where you can certify the avoided emissions from taking that biomass out of a heap where it could anaerobically digest and produce methane, you know there's a carbon asset there that can be sort of quantified. Similarly, when you put it through the pyrolysis machine, you get energy production, which replaces fossil fuel use. There's carbon reduction taking place there, and then you've got the single carbon removal function of the biochar because it's got its fixed carbon content. But then in its end use as well, potentially you could put it into a fertilizer mix. You could use it for a reduced irrigation requirement. All of them have a reduction in carbon use function as well. So you need to look at, in my view, the entire sort of end-to-end carbon life cycle in order to properly monitor all of the carbon reduction and carbon sink functions of that process.
So do you think there will be a LCA, life cycle analysis, credit versus just the output in looking at the feedstock and the value of harvesting it to the environment rather than just the carbon percent output?
I think it's more likely that you'll see methodology developers looking at multiple certification opportunities for the different sort of carbon reduction functions that I've just run through, rather than a single certification that can draw a circle around all of that. I think that might be too complex because it's so project specific.
Okay, that's what I'm doing. Thanks.
Okay.
So it's a matter of cobbling together different credits for the different stages of whatever process you might want to put together then.
Yeah, And as far as I'm concerned, I think that's a good thing, because what that means is that the biochar projects can get going now, where the door you're walking through is carbon reduction, because there are certifiable carbon assets in that whole cycle that what I've just described, and of which there'll be many other cycles, where there are also carbon assets there. So you can begin to monetize the carbon reduction impact of your activity while we're waiting for the actual, mythical biochar meth to get drafted and approved. So there's, for me anyway, that presents an opportunity to get going with carbon reduction biochar projects right now.
Is there still going to be the line of 50%, or does it matter? Why does the 50%
I can't answer that
when...
question, I'm afraid.
Okay.
I don't. I don't know. But if it means that it rules out several important categories of feedstock, then I hope not, because that would be a huge wasted opportunity. And plus, don't forget, we're in crisis mode at the moment, so I don't think anything and everything needs to be done. So I wouldn't rule that out by any means.
Thank you.
Just note a comment from John Miedema about the issue of defining biochar with having a certain amount of carbon. And I don't know, John, if you want to expand on that at all.
Here, let me comment on that, because the 50 or 60% carbon, comes from different sources for different applications. In the particular case of the use as soil amendment for the American Association of Plant Food Control Officials, the background there was specifically for labeling for application and as a soil amendment. And I think it's important to understand that those standards and regulations are a political process. We went to the American Association of Plant Food Control Officials thinking that we were talking to a group of scientists and bureaucrats who didn't have a particular agenda. And we found that 60% was landed on by a particular official who was able to sell the concept as being, well, here's a metric, here's how you measure the amount of carbon and biochar, and that can be changed and it can be modified. We haven't done that yet, but it's within our USBI ability with APCO to change that 60% number to allow what we had proposed was the IBI categorization of 10% carbon or more, 30% carbon or more, 60% carbon or more. And what they landed on was the 60% carbon. So in that particular case, that 60% number can be changed. For other uses, the 50% and so on, I think we need to look at what it's going to take to get the biochar products recognized and accepted.
If I can just jump in there, thanks, Tom. I appreciate what you're saying, but coming from the biochar community, it's really important that we don't, that we educate the regulators on just that, because, when we're making designer chars to get functionality and using the thermochemical process as part of the reaction body, we're engineering materials that are going to have high value, but we're impregnating the minerals within the carbon lattice work. And in order to do that, I've got to make materials that are oftentimes even 40% carbon based. So, that's just going to be part of what I'm calling, biochar 2.0. When we're engineering these materials through the retort, and we're having some very interesting, and I think it's been alluded to during this very good conference that I've been able to come in and out of, that this biochar 2.0 is going to open up some very significant markets, particularly in remediation right now. Harvesting phosphorus, starting to actually look at harvesting phosphorus from systems and making it plant available so that we can get away from the, my biggest fear in agriculture right now is actually peak phosphorus. And we have an opportunity with the nuances that we can do with the chars through the retort to solve some of the problems, I believe, in our agriculture sector for nutrient cycling. It's very, very important that we be able to talk about the amount of carbon within the material and how that carbon got into there, and we can base it on, you know, that unit weight or whatever, based on the life cycle of the machine. That makes sense. So if I have 30% carbon that's labile carbon biomass derived, it should have the same value as the carbon that's 90% if it's derived from biomass or whatever, if that makes sense. It shouldn't be based on the end carbon amount in that unit, you know, that pill, or in that, if that makes sense to you guys. Anyways, I'll let it go at that.
That certainly makes sense to me, in terms of being able to measure the total amount of carbon, whether it's 60-30 or whatever, and that's the unit that needs to be monitored and verified.
All right, so the chat seems to have toned down a little, and I'm thinking maybe what we should do is just go through the speakers for today and see if there's any questions on any of the talks that came up. And we could start, I guess, from the beginning. We'd start with me and the talk I gave, and anyone else associated with the Washington State University workshop. So are there any questions about the presentation I gave this morning? All right, so then we had 5 talks after mine, and the first one,
Yeah.
excuse me.
This is Mark Fuchs.
Yeah.
Hey, maybe you could, just for the sake of clarity, contrast the overall research picture that you presented versus the individual work groups. In other words, that there's sort of an overall large scale research program that you laid out. It was a long period, 50 years or something like that, multiple sites. But each of us in the work groups laid out a more discrete picture. And I don't know if that confused people or not, but I thought maybe adding some clarity there might be useful.
Yeah, I guess what I'm thinking is what I was proposing was sort of like in many ways an umbrella that would encompass the larger issue of the fundamental science that needs to be done. And that most of what was presented, I think, in the other groups, the working groups, was more bite-sized pieces of that, and also stuff that's more what we'd fall into the near-term research and development and the market development oriented side of it. And that's not to say that it wouldn't fall, some of it wouldn't fall in the more basic stuff, but it was meant to provide the underpinning for all the other work that gets done. Not sure if that quite answers your question, but the idea was more to look at some big picture things, big picture funding sources, and set them up so that that fundamental work would be done over the long term, and we would have that stability of funding. I know Kristen in her talk talked about the whole issue of stability of funding being a real issue, and in hers, of course, she was looking at a long-term project as well. And actually, it's part of what I proposed, I think, too. They overlap significantly, but I think the main issue is just that if we're going to do something with biochar, and where this sort of came from in my thinking on it was, in the first 10 years, we need to put a major effort into answering most of the big questions. And then in the following decades, we would sort out things like, okay, longevity in soils under this treatment or that treatment, and so on and so forth. Some of these longer term questions would be answered, but in 10 years, and even in 5 years, in some cases, if we put enough effort into it, we could pretty well answer any of the questions that are out there. But there's a lot of work to be done developing new, there's a whole engineering task. There's another task that I didn't mention that could probably easily fit in there that has to do with the non-biological uses of biochar after it's created. And these were talked about by several speakers in the conference. So the point is, we need a good solid decade of intense effort to really push the limits and really define things down to the point where in subsequent decades, people have a much better idea of what sort of policies will work and where the profit is to be made in the whole thing. I don't know if that helps.
I think that's useful. And I also think that amongst the 5 work groups, there was a lot of opportunity for working across those work groups from one work group to another, providing char from, work group 1 to, the compost group or the agricultural, long-term agricultural uses. So there's a lot of opportunity to integrate those ideas that we threw out.
Yeah.
Could I just say work group really quick that I don't know if it was made really clear today? I think the one thing that I came away from is independently, each group talked about the high importance of integration of biochar and biochar production within a larger system. That, we have to find all the ancillary benefits of biochar and its production pathways. And we can see that there's all kinds of different chemical constituents that can come off the vapor state, and there's all kinds of, and there's heat that's made, and then there's the carbon itself, and that we have to find value in the heat production, or we have to find value in the carbon, in all of the constituents that come off of it, and integrate it within bigger systems. We co-locate these systems, I think, is really, really important for the longevity of it becoming a valuable pathway. I for my own, like the way we've done, like looking at different models, the only time it ever kind of pays back is when we integrate within other systems. That was kind of one of the things that I took away, is that I think all of us across the different work groups talked, that integration was important.
Okay, so any other questions for that 80-minute segment? Gloria Flor gave a nice presentation on their working group idea. Jim Dooley gave a presentation. He's not here, but I noticed that Hansu Pan, who was a co-author of that, is here, and he's available to answer any questions. And then we went to Tom Miles's presentation. And then Mark Fuchs, and finally Kristen Tripp. And if we have any further discussion, that's fine. We can move on to the other presentations that were made this morning, because we have about 20 minutes left here.
Can I ask a question in relation to what John, forgive me if I've not pronounced your surname correctly, Miedema just asked? You were talking about the fact that production systems need to integrate with as part of larger systems. Do you mean larger production systems in addition to the production of energy, condensate, wood tar, and perhaps carbon credits? Is it are there other sort of production systems into which a biochar production system needs to be incorporated, in your view, in order to be profitable?
Well, I think you need to include waste recycling at some point. I mean, like for one of the models we're looking at here is taking in food waste, using waste heat to support worms, in the Pacific Northwest all year round. Doing the condensing of the vapors so that because I'm curious in some of the things that we're seeing with the pyroligneous acid. So for us, the worms and the food waste and the tipping fees we can get from processing food waste and fermenting it is some of the other things. We looked at, I thought, a very interesting integration of the shrimp farming one that was talked about, I believe, yesterday. It's those kind of systems that I really see higher values and further integration of, nutrient cycling in that case, right? And nutrient cycling in the case that I'm talking about. Yeah, that's what I mean. Like, we have to kind of eke out everything we can out of the thermal load. Like up here in the Northwest, we could potentially, co-locate with hemp dryers, because there's a lot of seasonal drying of food around here, or agricultural products. And, we have to find those values in the forest, that's one of the things I'm really, really interested about pyroligneous acid, is because that's, when you look at the mass, generally, if I've got this right, and Tom can correct me, it's about 30% of the mass balance, and about 5% of the energy. So you can imagine, if we can find value in that aqueous phase that you can export, and there's all kinds of anecdotal evidence and some good work that use as an antifungal agent for agriculture. Those types of things, we have to find all the values that are potential.
The acid that you're talking about, is that also known as wood vinegar?
Yeah. Yep.
Yeah. Okay.
And it's something that needs to be investigated, because there's potential toxins in there, right? We see values, but I don't know that anybody's to my, I'm a first do no harm kind of a researcher, right? And I think while we see great values, I personally am not going to sell that stuff to anybody until I see toxicology studies done, and they're not cheap to do. We have to understand what we're putting out there. And but there's real value for us as an industry in that pyroligneous acid, potentially, and we have to understand it, because that's something we can take out of the woods and use if it has value, right? There's every indication for us in the Northwest. Our forests are seeing the Swiss needle cast. Swiss needle cast could potentially, within my own studies, there's some potential there that we could maybe benefit something like that. I'm not saying it does, but we need to look at it. There's some real values that we could squeeze out of that part of the equation.
I agree. There's a good case study of that happening in Cambodia, a project being implemented by the Husk team, HUSK, which is definitely worth looking at. They're selling wood vinegar as, I think, a biostimulant and also a natural herbicide. Yeah,
it's been used through, there's quite a bit of history of its use, and there's a lot of around the world. The problem is, in North America, we have to do the research here with our universities here and public here.
Of course.
To get allowed.
Yeah.
And
I would love to see a competition. I thought about this before, from a systems standpoint. Could engage all the big universities and to figure out how it's sort of like the X Prize, but coming up with the most total use of all the pieces coming out of the biochar process, or something like that. I think we could go far if we had some sort of a contest to challenge people to try to come up with these whole systems thinking. I don't know, just an idea.
Maximum carbon benefit or something like that. Maximum utilization of the carbon for minimum waste
in the whole process. Kind of like the shrimp idea, where they're utilizing every single piece of it and there's no waste. That type of a system, and it's just what John has been talking about, is getting the most bang for your buck out of the process.
I had a quick question. So we heard Kelpie Wilson's presentation, which I thought was phenomenal. And her approach is distributive type of systems, small systems that are mobile. And then we also heard, and I forgot which presenter came back today, I think, with a discussion about larger systems that are more centralized. And I thought, I just wanted to ask, does anybody think that there's one benefit over the other, or is it project specific?
I think it's project specific.
Well, This is Han. I would like to chipping in a little bit to answer the question. My group, group 2, we've been focusing on the mobile biomass conversion technologies. It's sort of the moderate scale. So you're looking at 10 to about 10 to 30,000 ton of so less than 10,000 ton of the biochar production per year using mobile biomass technology. So idea behind that is about trying to minimize handling cost, the transportation cost of the hauling raw material to the one central fixed location. So by converting the biochar near or in the forest, you can effectively reduce the volume and the weight of the feedstock, converting into the biochar, which they help reduce the transportation cost significantly. Based on our waste to wisdom study, we could reduce the transportation cost by 160% by converting the feedstock into biochar. So there is a significant benefit of doing that. And then once you have the limited the hauling cost from the forest to the conversion site, it become a longer, say more than 10 to 15 miles, then you can move that unit to the location where you have a more close access to the biomass. That is one of the main benefits of what we are looking at. Another idea is related to that is the volume of the material is highly scattered, small volume scattered. So in that case, one central location, hauling the large volume of the biomass into one central location becomes very expensive. So I think that is, one of the main benefits of having a mobile unit compared to one fixed large-scale unit. The main downside would be the production cost of the unit, production cost of production of biochar, producing biochar, would tend to be much more expensive than one centralized large-scale production operation.
It's not mutually exclusive at all. It's all site-based. Especially when you're talking about forestry and forest biomass, there's such a variety of different situations. So for instance, in the wildland urban interface, you've got in my county, there's like thousands of small woodland owners who have 10 acres or less that they're managing. And there, we also have Biomass One here that's one of the biggest biochar producers in the country. And they, I work with them a lot. They love what I'm doing because I'm actually promoting biochar, by reaching out to people, like getting them to experience it firsthand, learning about biochar. But more than that, they can't send out a grinder and a truck to pick up a little pile here and a little pile there. So even when the distances aren't great, just the fact that it's scattered amongst a lot of different ownerships, it's not efficient really to collect it all up to send it to Biomass One, even though it's only 30, 40 miles away. So there are just so many different issues around biomass handling that we need all the tools in the toolbox for this.
Yeah, Kelpie, you made a point right. I think a very good point you made it. Yes, I 100% concur. The things. That's another the things I was going to mention. That depending on the situation where you can apply the very small scale, the biochar production. We can Kelpie mentioning. And we can use moderate moderate scale using mobile technology, or one big centralized scale operation. I think the combination of all of those, like use all the tools as you that Kelpie mentioned about all the options, whatever the most economical, most financially beneficial. I think that should be the way to go.
I think another one that we haven't really talked about at all here, which I think is really important for the multiple benefits, is the combined heat and biochar type of furnace that can be designed and used in a small industrial situation, like a small timber mill for lumber drying or food processing. That there are, and Tom and I did this study for university or for Nebraska Forest Service on this, looking at existing technologies that are quite affordable, and small biomass heating plants that make biochar are really feasible in these situations where they can draw from a closer in kind of woodshed to operate, and it could be very economical.
Is that a proprietary study, Kelpie, or is that available through USBI somehow?
That is now a USBI white paper, and it's on our website. We have started a biochar learning center. This is one of our big initiatives right now. In addition to reviving the newsletter, is we're going to be creating a database of materials, and we have a committee, that's reviewing them, because there's a lot of information out there. And, we just did a survey asking people where they get their information from, and they get it from a lot of interesting places. There's a lot of YouTube videos out there where the public is getting its information. Some of these are very good and some of them are not so good. So what we're trying to do is create an information hub and a database of resources that are going to be useful and helpful to the end user of biochar.
I have a recommendation, Kelpie, since you're doing that anyway. In the EU, when we did cost, we created what's called a charchive. It's an archive of chars. I think we got over 10,000 of them there. So that's something that we might want to put together here in the United States.
A database of chars with characterized chars?
Yes.
Yeah, UC Davis has something like that, and so we'll be linking to that for sure. But good idea.
Yeah, and I think it's also great if we could around the world, because you got a lot of people stovepiped. And what I liked about this whole forum is that we're getting rid of the stovepiping around the world. I mean, you've got Simon Manley from the UK, you've got people from all over the world. I would encourage that we do more of that.
Agreed.
Absolutely. We're running down on, we've got about 5 minutes left, and I just want to quickly run through the other speakers who haven't had any chance to perhaps have any questions for them. I think Steve McCorkle is still with us, and he talked about scaling production of carbon negative biochar and jet fuel. Are there any questions for his presentation?
I just had a quick question for Stephen. What was the throughput of your systems? And I got, I'm not sure if it was your presentation or somebody else, but sometimes I see in the presentations the term gasification, gasify, versus pyrolytic carbon capture or something like that. Were you using pyrolysis and gasification, and what was the throughput?
So we are using pyrolysis. To answer your question, can you hear me okay?
Yes.
We're using pyrolysis, and then we're taking the syngas to convert it to Fischer-Tropsch jet fuel.
You're kind of fuzzing out.
Yeah. I heard you in the beginning, but then you fuzzed out.
So we're using pyrolysis to form the syngas, and then the syngas is converted into the Fischer-Tropsch jet fuel right on the site. The throughput, we have fairly small units that can be placed in parallel. So 1 ton per hour type of units for both the FT and the pyrolysis unit. But it makes permitting much easier, especially here in California, because they are temporary. They can be temporarily permitted. They can be scaled up. Regulators are much more comfortable with something that doesn't have permanent infrastructure in the ground, like these biorefineries or ethanol refineries, that are just western bolts in the landscape. They're much more comfortable with something that can be moved right to the source of the feedstock on the farm. And then if the farm goes out of business, or fire project, or whatever happens in the natural disaster sense, forces you to leave, and you simply disconnect the equipment and move it out. It's all truck movable. including our buildings. So they're all temporarily permitted, which is a much easier way to get permitted here in California. So the products that we produce are both in terms of biochar and Fischer-Tropsch wax and liquids, and mostly wax, 80% wax through our process, which is a very attractive kind of feedstock for refineries because it's a 95% refined product that can be hydrocracked by any refinery, standard equipment, into jet fuel, kerosene, whatever they need to make their quotas and RINs credits, but it's sulfur free. And it costs an oil refinery a lot of money to refine out sulfur from petroleum-based fuels. So just blending in some of our sulfur-free jet fuel saves the refinery a lot of money to get those sulfur levels down, even for ultra-low sulfur California diesel fuel, 15 parts per million sulfur content. But the point is that we're leaving the plant next to the feedstock instead of the other way around, so we're saving the largest cost of biofuel production, which is typically the feedstock, and the highest cost of the feedstock is transporting the feedstock to the central plant. So we're moving the plants to the source of the feedstock, and then we're creating this energy dense, compact in volume, Fischer-Tropsch wax and biochar products, which are very easy to transport to final markets, and of course, in the agricultural environment, the final markets for the biochar are right there with you. Does that kind of answer your question?
Yes, thank you.
You can only hear a little bit of that, actually.
Oh, really? Is it my?
I heard it. I didn't have too much.
Okay.
So Raymond, can we just continue on here for those who are interested?
We can go another 15 minutes. I gave it
Okay.
a minute extension if anybody wants.
Okay. I want to move to Gloria Flora's presentation, Building a Sustainable Biochar Industry. I was curious if there are any comments or questions for Gloria.
Well, I think it's, one of the key components that we need to examine moving forward, as I said before. I think we all need to be aware and to, look over those great slides that she had and examining what we're doing and are we actually doing things as we should instead of doing things as we're just used to in the society that we're in. And so anyway, I really appreciated her comments on that.
I'd just like to make a comment with regard to the whole air quality issue with regard to the sustainability. It was one of the components when we put together our workshop was to try to bring that sort of issue forward in terms of design of new systems and holistic outcomes. I think Gloria hit that really well, but more generically around the ecological benefits. But the air emission issue is a big deal. And any of our work working forward with new systems really needs to have a good look at that.
So I couldn't agree more with that statement. We're all about the air emissions in Southern California with South Coast Air Quality Management District. We've got the only pyrolysis unit that's ever received a full operating permit from South Coast, considered to be the most stringent in the world now. They set a lot of EPA standards. They set standards for Detroit. And their claim to fame is cleaning up the LA basin, by a factor of 4 times in the last 25 years. So,
I wanted to make a quick comment too. We've been working with CAPCOA, which is the parent organization of air districts in California, and we have a real booster there. And we've got a proposal to them to do emissions testing, both in the field and at the Montana Fire Lab for open burns versus conservation burns versus the kilns, ring of fire kilns. So we're working on that, and I think getting that data is going to be really important. Jim's involved in that as well, Jim Eminet, and we're hoping to get that funded. So that is a critical factor, although you have to compare it to what's happening now. And what's happening now in a lot of cases is just going up into smoke. And any way we can improve that to us is an advantage, but we need that real data. We're working on that.
One way you can improve that is keeping the syngas from going up in smoke by converting it to something like jet fuel.
Marshall, you were gonna say something?
Well, I had kind of a question. In her presentation, was it her presentation that talked about the uses of char? In other words, the markets? Was that where she said 54 markets, or was that somebody else?
That was me.
Yeah. So, oh, that was Gloria. Okay. So sorry. Because I was just going to say, if you read the latest book by Kathleen Draper and her co-author, she wrote that article through the Ithaca Institute on the 55 uses of biochar. But as of last year, she's already acknowledged 100,000 markets. So, and as co-chair of Working Group 3 on the commercialization of biochar in Europe, I concur with her that there's that many markets out there.
Yeah, I was speaking about generic uses and not markets.
Okay, I stand corrected. Sorry.
Not a problem, but I'm glad you added that important fact. There's actually 55 if you include transporting dead bodies. As per Lonesome Dove.
Actually, I know all about that because our systems are manufactured in Italy. And when the regulatory bodies there came to us during the pandemic, they want to know, can we still manufacture? And our systems are being manufactured, but not for pyrolysis. It's actually being manufactured for crematories because of all the dead bodies from COVID.
Yikes. I was not talking about the cremation side of it. I was just talking a little tongue-in-cheek about the book Lonesome Dove, where the main character's body was transported from Montana to Texas in a casket stuffed with biochar.
Right, yeah.
Anyway, we need to get Paul Simon to write a song, 50 Ways to Stash Your Biochar or something like that. Let's move on to Josiah's talk, leveraging existing infrastructure in California. 250,000 tons of biochar per year in 5 years. Are there any comments, questions for Josiah?
I think it's totally doable what he's saying.
I do too. I like the use, Josiah, that you've made of your California biochar model, and one of these days we're going to sit down and we're going to work to splice it in with the stuff I've been doing, and I think there's a lot of value that can be gained from doing that. So I just compliment you on developing that and doing it the way you have.
And this is really low-hanging fruit.
Yeah. So I put up a question a little bit ago there. Also, I'm really interested. Well, I guess we can get to that. There is one more speaker after me. Jim, I just wanted to bring that your attention to that question I put up there. That I'm really curious to hear from somebody outside of the biochar industry, maybe somebody who might have been viewing this for the first time or is viewing this with ideas of donations, investments, or collaboration within the industry. I'm really interested to hear what they might have to say about what they've seen in the past couple of days. So I think Tom gave a great presentation after mine. So then maybe after that, we can open up that other question there.
Thanks, Josiah. Yeah, let's briefly just move to Tom's, then we'll come back to Josiah's question. Any questions, comments about Tom's presentation on building capacity in biochar advocacy and education organizations? All the I's, the IBIs, the USBIs, the SBIs, and so on.
I think the reality is we just all need more money to build capacity and work on the programs we want to. And so hopefully we can continue to market all of these great presentations. And, you know, even those that couldn't make it or maybe, you know, didn't want to spend the time, we can still, I'm still going to be sending out to all of our big list of the other philanthropies and social impact investors, et cetera. And I encourage you all to do that as well and send them to the website to listen, because I think that's how we're going to gain more interest, for sure.
Kelpie has a comment, I think that's relevant to Tom's presentation, which is, should we consolidate some of these organizations? I think it's a great question, and it also ties in with the thing that I suggested yet another organization called the Endowment for Biochar-Based Community Development. And so this is a question that I think needs to be considered, is how do we best organize ourselves to be most efficient? And is consolidation a wise thing, or should we maintain our diversity the way we are and sort of let them go as they can? Any thoughts on that?
Well, again, there are, just like, you know, that there are many different ways, and, you know, it's place specific. And yeah, I think that there are sort of on the ground uses for more regional organizations that you can't do, you know, on a national level. So I'm not sure how we consolidate necessarily, because we're sort of attacking different things. We're doing on the ground trainings and education and more community-based stuff. And, you know, the national and international groups are doing the important work that us little guys can't do. So I don't know. I think it's certainly worth talking about.
I have a recommendation. I belong to a number of different organizations because of the different things I'm involved in. And a lot of these organizations, I have an umbrella over them, and then they have regionalization that are kind of independent, but filter underneath the umbrella organization. That's one approach. And it's very common in the United States and also around the world.
I think, you know, on the topic of consolidation, we're looking at consolidating the I's, as you would put it, I think, Jim Amonette, International Biochar Initiative, United States Biochar Initiative, Sonoma Biochar Initiative. I think that those are actually, you know, a nice little size, their scale. You know, Sonoma is a locally focused organization. United States Biochar Initiative is a locally focused organization with a large region, with a larger region than the Sonoma Biochar Initiative. And the International Biochar Initiative is, of course, focused on the region of Earth. Where I see a lot of overlap or potential redundancy is that across the pond, over with the European Biochar Certificate, there is, I guess, a covergent evolution, you know, where they're developing a lot of the same things that the IBI and USBI are developing in ways that I think do offer greater opportunity for collaboration and or consolidation. For instance, the IBI certificate versus the EBC certificate, the methodology, such as the carbon sink guidelines. And from what I understand, the IBI is now undertaking another development towards a methodology. So I do see, and I don't think we've talked much about the EBC, which is interesting. I do think that there is a lot of potential there for collaboration, consolidation of some sort, and I'm wondering if anyone else has some thoughts to share on that.
Yeah, speaking from that side of the pond, I agree. I think that the IBI and EBC work does cross over. I found it surprising and astonishing. 10 years ago, whenever it was, when the EBC certificate sort of popped up, and it was such a small sector back then, and to have two certification bodies with such a small sector seemed crazy. But they do some fantastic work, and as does the IBI. So I think to combine the expertise and the outputs, I think would be incredibly valuable to create a more sort of international movement.
I should mention we have a discussion of that very issue with some input from Hans-Peter Schmidt in the report, the biomass to biochar workshop report. And it's an interesting discussion. So
it would be great to have one organization that could take in all the money. Everybody could focus it on that organization, and then they could distribute it to everybody else in some way, because everybody's going after the same sources of money in many cases, including in grants and everything else, and we're all competing against each other. So it would be something to think about, if we could consolidate that together, especially the fundraising, but then everybody could get some money from that.
I think that's kind of the thinking behind the endowment, to let the financial side of it go through something like that. All righty. Well, I think I just want to thank all the speakers for presenting. I know it was a lot of work, and all the participants for asking questions. And I think we had a great discussion this afternoon. And to stay in touch, we can go to scalingbiochar.com and see the final version of this when it's all wrapped up. So I'll turn it back to you, Raymond.
Yeah, thank you all. Really appreciate it. And hopefully this has kind of opened up a whole new audience, and we can push this thing forward. So thank you all. Really appreciate it.